How's it going, everybody? Eulier Gonzalez here, and today we're going to talk about is the OOP in JavaScript and how that plays out, especially when we want to build applications that are scalable, so easy to maintain, easy to debug, and easy to test, which actually is now recently much more easy to do that, especially with the new advancements on the language thanks to the TC39 commit, which is the designer teams to push forward the language, specifically the ECMAScript specification, and now it make it much more, even though that the prototype oriented nature of the language, the way of how you can share functionality in a memory efficient way to data, is that now looks like more like other object-oriented programming such as Python and C Sharp. So the idea here is that once we are now able to look at how these things is working behind the scenes and what are the new advancements on the language that allows to write each application that look like similar to any other languages, we can now reuse some of those concepts and, so to speak, and swap between one language to another. The subtlety between it is on the syntax, but the fundamentals remain the same. Not only in terms of the data structures, which is something important, but also is on the algorithm, how we're going to write all of these series of steps, and how then can we organize is our data or applications in a way that we can easily manage. So how can we organize the data and the relevant functionality here in these objects, so we can now make it much more easy to modularize, easy to maintain, debug, and test each individual objects. So that's the whole point of the OOP programming. And luckily for us, Will Sentence, which is a software engineering that has previously worked in a tool called IceCom, which is a P2P sharing applications that now you can actually use something called WebRTC to guarantee this real-time communications, which is kind of an interesting. Is that actually is also quite powerful features to build with, and how WebSockets allows to do that. But currently, he is now the CEO of Codesmith, which is the software engineering machine learning residency based on London, New York, and California. So on that topic, okay, and to know what is the goal of this course, and then we're going to talk about the goal of today's video. First is look at how this paradigm, this approach called object-oriented programming, allows us to write applications and programs in a scalable way while being professionals in an engineering environment. So why do we matter about doing things at scale? That's one. And the second, why does it matter in a professional way, of the work ethic? So the first is because this is not where the business and the economy came here, that particular science. And it say, hey, you know what? As a way to grow as society, okay? If, for example, we want a mouse or a cell phone or for example, foods, different type of foods, it is important to produce them at scale. So because now, well, more people can have access to each one of those resources, now they will have not only much more time at hand, but also they can use all of these devices and goods and services will make them allegedly, in theory, much more efficient and much more performance, so that they can dedicate their time and energy to things that matter the most, not only for the economy but also for themselves, which ends up creating its own economy, which make them part of this giant economy mechanism. So, okay, this is just in theory, right? The practice is that we are not that quite efficient, and people actually have different attitudes toward life. Most of them, some of them prefer to dedicate their life to business or the arts. But in any case, and in today's video, and when in a professional way, is because you want to do that in a way that what the more consistent you show your work here, the better your reputation will be around this particular topic, and the word profession or professional comes from this old French word, according to etymology online, from the French word circa 12th century, profession. I think I mentioned that right. So profession, that means take vows at joining in a religious order. And right now, well, perhaps it's not that quite secular. It is in terms of more psychological aspect, or in terms of, if you're going to dedicate to this, you better off do that, because otherwise we wouldn't take you serious anytime you talk in these particular topics. That's one of the reasons why, for example, now science, which has become our new kind of religions, because it allows us now to, whatever we say, we can replicate that. Okay, so it's this testable model. So you have now a way to, based on an hypothesis, you put a test that you come up with a outcome, with a result, and then you can now test that, see the results, and you're always gonna get this predictable outcomes anytime you perform that test or that hypothesis. So now that becomes is a testable model for hypothesis. And I think that's something, especially as we grow up as not only as an individuals but also as society, that it is good to be a kid. Everyone loves to be a kid because we don't have that much responsibility. But now as we grow up, and now as we starting to embrace generally this responsibility, we can now face more complex problems. We can now have better problems, and this is one of this. And life becomes much more rich anytime you look a new challenge. The problem is that all of this new challenge or all of this attitude most of the time comes with new generations. But right now, that's happening in a so fast pace that we have to do that in our own life, every day, every second. Again, I didn't set the rules. I'm just observing what people, for example, in not only the tech industry, but also that are people that are pushing the boundaries because they realize that in order to have a meaningful life, again, this is one particular way of thinking. So, in order to have meaning in life, we can define life as this some sort of game where we pass from one challenge to another, the next stage to another, and that kind of thing. Uh, yeah, this is kind of an interesting theme. Uh, and again, in today's video, what we care about is to, well, not only to improve our communication skill, which is something important, technical communication skills, uh, especially if you're going to talk to a client, a non-tech savvy or a tech savvy. Okay, so you are get familiar with them, and also you can make complex topic, abstract topic, meaningful to not only your college, which is something that the senior developers actually do by themselves and also in their companies, is also go beyond that and provide value to the shareholders, to the business, to the college by giving meaning to uh, the rest of the team. So this is not only comes here, or this is not only for senior software engineers, but also for any senior citizen, okay, that now can provide this huge amount of value that society perhaps doesn't know that it wants to, but it needs to. So, all right. So that's one of the reasons of why I'm recording this series of videos as a way to improve this, not only analytical thinking, analytical skills in real time, but also is the technical communication. So based on my approach, can you implement my approach based on my description? And that's important. uh, and then, well, for example, follow is the best practice. These soft skills, so be empathetic, have patience, and also it ultimately is now the language itself, how the language works, the specification, and that kind of thing. So as you can see here, we are now not only as software engineer of senior software engineering, dealing is with the theory, okay, the specifications. We also now dealing with other faculties involved, and that is psychology, and that is the social aspect of ourselves gathering together to build something, as well as business and market. Is that how valuable or how can we now provide is meaning to others based on our understanding, and how can we convert those technical skills in economic output and things that actually can satisfy is the needs of our users and also of our shareholders. That's lovely. That's something that is quite painful, or at least in my case has been like that, eh, because it attempts a lot. It hits your ego vastly, vastly. Uh, and again, there's some stuff that you didn't know, or that you need to know, and it is not your fault that the world it is what it is, or that you didn't know about that, but it's your responsibility to get it. Anyway, so In today's video, we're gonna make a quick recap about this particular course as a way to say this is something, or what is the core sections here. I already mentioned is the introduction here, which is the core section here, is to look at the introductions, and then we're gonna see the introduction of object programming, and then we're gonna look at the how can we create objects, literal dot notation using the object.create, then create object with functions. What is the benefits? What is the trade-off? Why then we need to take a look at a different approach to write object with functions, because it can become very tedious and monotonous doing all of this handcrafting when it comes to create objects. And what is the way of how JavaScript allow us to create now objects using the new keyword or this specification, all right? And how we need to organize our code in a way that satisfy this new way of creating objects, and that is understand what is a prototype. Okay, what is how this sharing mechanism of functionality in a memory efficient way works, and how new behind the scenes create these objects. So anytime you create a function or anytime you create a object from a function using the new keyword, it'll create is not only a brand execution context that is setting the value of this to empty object at the beginning, and then analyze and then added all of the property and all of the property to this object, okay, to this value here as an object, and then create is the link, which is anytime you create a new object, JavaScript by default has this hidden property called prototype, which is a bad name, which is badly refers because browsers refers to this as the proto. Okay, so behind the scenes, JavaScript create is now when create a new object, it set this hidden property called __ proto __ the dunder, and they call the dunder to the double underscore. Since this is a Python thing, according to Brian Hall, so this is a Python thing, and it is quite funny because the dunder is this substance that sit on the bottom of a bottle, that sit on the bottom of the bottle, from boiled cane sugar as part of the distillation of rum. So yeah, it's like they say, hey, do you remember whatever sediments deposit here in the bottle? Well, that is the dunder. So they call that the dunder. So the dunder, proto dunder, that has a reference to the prototype object that was created, which now it has a reference to the function object constructor. Okay, and a quick side note here, the function object constructor, according to the specifications, it generate is this hidden property called prototype. That this is when you hear a lot of people say, hey, put in the prototype, put in the prototype. It means that this is a store where you can add all of the functionality for your store or for your objects. Okay, so knowing that, okay, and that this is what the new keyword is doing. It created this new keyword, and then the product link to the prototype function object creator, okay, where it contains is now all of the shared functionality that we're going to receive that in a memory efficient way, and then ultimately return the entire object. So now that I know that process, you say, well, once you know how these things work with the new keyword, it's actually quite familiar to go with. It's actually pretty easy to follow. It's less verbose, that's for sure. Uh, but when it comes now to adding more nested functionality inside of our prototype functions, oh, then it's when things get quite interesting. Do the JavaScript, to the nature or to the dynamic nature of JavaScript, especially with the this and the scope. So, for example, if you define on the prototype a function, let's say increment, right? And inside of that function increment, you define another function that is, for example, add. Okay, let's go to add number here. And then you run that function inside of that function. What happens is that the value of this changes. Why is that? Because after all, the value of this is whatever is on the left side when that function was invoked. Okay, when you invoke that, okay, at that moment inside of a nested prototype functionality, okay, where we host our add function, what happens is that the value of this, by default, if there is nothing on the left side, it points to window object. So there is a couple gotchas and way to fix that. Actually, this is a pretty this is a design by the way. This is that's quite becomes the solution by de facto, that hold the reference of this value into a that variable or to self, okay, and then actually now work on that current data, okay, work on the relevant data, so apply the functionality to the proper data. That's quite interesting, and that is one of the reasons why so this is one of the reasons why a lot of these questions are being asked in interview, in companies interview, because they know that if you know these things, now you can provide value to the company, and that's what ultimately what they're looking for, since they are in a very competitive space. So actually we want us to now collaborate together and find a way to thrive as a company here. Okay, so far so good. And even though that this approach works quite well, okay, the JavaScript developer or the JavaScript designers were ashamed of the OOP sharing mechanism. You know, they are ashamed of of this POO nature. You know, and they say, hey, would it be better if we actually find a way to, instead of defining is a function constructor where we're going to put all of our data, and then define is the methods under the prototype of that function constructor, wouldn't be better to actually do that in one single construct? That's what we have is class. In class, what it's doing is in one single construct, one single place, let you initialize all of the data as well as all of the methods or functionality that can be applied to that proper data. So something that all other programming language like Python and C++ actually allow you to do that. I don't know what is the inner mechanism, what they're doing to share that property, but quite frankly, it's not POO. What I think it is not prototype object-oriented programming. It must not be that. So in any case, so now that we refresh our concept here, and we were able to describe in a very succinct way not only the introduction of object-oriented programming, and what is the reason of why do we have this approach, is because programmers in the 60s realized that we need a way of how we can now bundle relevant data and its functionality together. Okay, so it makes our life much more easy when it comes to develop applications, and that's why later on came out things like the clean architecture, or things like how can we now organize our way, or the solid principle, some sort of principle, especially when you're going to write applications using this paradigm in a way that you don't shoot your foot down the line, right? That you have solid principle, which stand for single responsibility, open close principle, which is open to extensions, close to modifications. The L stands for the list of substitution, list code substitution. The I is for interface, if I recall that great. So to do solid here, you got it. Even exactly. The list of substitution principle. We also have is the interface segregations. So let's go to create now a general purpose interface where now you can from there is create several interface from that. In other words, several ways of how you can interact with these objects. In other words, like what are the several ways of how you can interact with your cell phone, for example. Hey, you can now is grabbing is with your left hand, or grabbing with your right hand, or grabbing in this position, or a little bit here, or like this. Which one of them actually result much more better to interact with them? Oh, it's quite frankly this. All right. So again, how you interact now with this object. And the other is the dependency inversion principle. Is that depend on abstractions, not on implementation. And again, too much abstraction is the enemy of the good maintainable code. So, but you get it, right? This is one of the things that you have principles like KISS, keep it simple, stupid, dry, don't repeat yourself, and that kind of thing. And the thing is that with dry, most of the time the code is actually so most of the time, a lot of the time, is that repeated code is cheap, and in the market, sometimes that's what you want. Anyway, so yeah, here in today's video we're going to talk now about the default prototype change, and how now by looking at this weird nature of how we need to set this inside of the function we define under the prototype function constructor, function object constructor, the JavaScript designers say, hey, we're ashamed of our prototype nature, and we wanted to now find a way to make our code look like more similar like other object-oriented programming. So, for example, Python, you know, and that's where we have here the class keyword. But before going to that, okay, we need to now find a way, or we need to know first is how the prototype works by default, the default prototype change. That's what we're going to see in today's video. All right. Yep. So the default prototype change. There you got it. All right. Object default proto. Exactly. So object default proto. So object default underscore proto underscore. That's right. Function prototype and an array. Function prototype and array the prototype. As a way to look at this function prototype in array. An array prototype like so. And ultimately is this pair programming. You guys see, so pair programming in OOGSX, object-oriented in GSX. Okay, this is the subtopics that we're gonna see today. Let's get into it.
In our first line of code, if you can just verbalize that for me so I can then diagram it out and we can kind of make sure we're continuing to refine our technical communication. What are we doing that for?
Exactly. That's the entire reason that we're doing here as a way to refine our technical communication here. That's it. That's it. That's it. Come on. All right. So let's describe verbally. So let's describe verbally the following code as a way to keep improving our technical communication skill. Right? All right.
We have a const,
right,
obj, that,
we can pronounce it obj.
or object.
I don't know if that's allowed, but yeah, obj, exactly. And
exactly. So we're going to reserve spacing memory for our label called op, or we're gonna reserve spacing memory for our op label that their value is a num key and 3 as value
is
An object.
an object. Fantastic. There it is. Okay, and what property does it have? Immediately assigned to it. None. Yeah. Fantastic. Well put. Okay. Now, let's go and access it. In the very next line, Michael,
Yeah, we'll put.
talk me through accessing it.
We are calling obj and
Careful using the word.
Exactly. So here we are now accessing to the num property from the op, okay? And if that exists, okay, you're gonna have the value of that. Okay.
Calling for an object, that's for function. So we're I would guess we are looking up obj, or we're
Accessing.
referencing obj, or we're looking in memory for obj, and we find it.
Yep. We get the property name num.
Yeah, exactly. Which is the value
3.
3. What? Easy. Or maybe not. Or maybe easy. Ah, let's use this next property. Obj dot has own property, and it's a function that takes in an argument, the string num.
Mm-hmm.
Let's do the lookup.
Exactly. Let's do the lookup. It's like, what is has own property? What is this? Okay, where is this method come from?
Michael, where do we look for obj?
In the memory.
In local memory, spot on. Yeah. Find it.
Exactly.
Yes. Where do we look for has own property? You look for it on the object,
Exactly.
right? It's just like num. We found num. It was there. We look for has own property. Is it on there?
I won't see it. Well,
It will see that. It will panic. It will take a look at the proto.
Definitely not. But we do look on the object because it's a property of obj we're trying to access. Do we find it? No. Do we give up?
No.
No. Where do you think we might go and look? What hidden property? Yes, David, I meant to ask somebody.
On the proto.
Spot on, you're right. A hidden property proto. A hidden property proto, but where's that linking to? Okay, now we need to know about something that is built into JavaScript as soon as we turn on JavaScript.
Mm-hmm.
That's correct. As soon as we start our runtime, our JavaScript engine up, as
Mm-hmm.
soon as we do so, it automatically adds in the background this. No, that word is ruined. Automatically adds, wait for it, a function object combo with the label object. What would object be, do we think? Oh, probably an object. No. It's a function object combo. It's a function. How do I show these as being fundamentally, they're built in? They're not, we don't assign these, we don't declare these. They're like, I'm going to use orange to sort of mark off stuff that we're not assigning. It's there in JavaScript by default. Okay? Not very clear. I don't know. Maybe. Does that, yeah, you see that's in memory, but we're not putting it there. And one of the first things in there is called object. It is a function. It's actually a function that, by the way, when called with a new keyword, is going to return us an object. But we don't need to worry about that for now. It's just an object. So no, it's not. It's a function. But it's a function, therefore, must also be an object. So it's a function and also an object. Okay? There it is. There's object. There's the object. That object, by default, as all objects in function-object combos have,
As all objects in object function combos has prototype.
has what property do we think, Chris? What all objects
Prototype.
in function combos have a property by default? Fantastic. Thank you, Chris. Yes, prototype. Well done, man. Which is itself a big old object. Sub-object, I guess. And that object has a function on it, a property on it called has own.
By default. Mm-hmm.
It has a few others, like 4 or 5 others. One's called, I don't know, what are they called? Like 2 locale strings. There's like a few others on there. There it is, has own property. And this object here is what our underscore proto underscore points to this object here, the object.prototype. So we'd see in here.
Quite weird? Yeah, it is.
So Seth, talk me through the lookup process on obj.hasOwn property that Java will actually follow.
So it's going to look on obj in global memory. It's not going to find it there. It's going to freak out a little. Then it's going to look in the proto. Look in the object. Look at its prototype.
It's gonna look at the object. Exactly. It's gonna look now at the object function. It's gonna look at the object function combo, okay, which has a prototype
Find has own property.
that now is say, hey, do we have this thing called has own property?
Excellent.
Yes.
Call it and check on off
Mhm.
none exists and we'll give us back true. Okay, folks. This is to say, I would call this dog fooding. JavaScript dog food, that's that phrase meaning we use our own product. Dog food's its own prototypal nature. It wants all of its things it creates, that we create, but also any objects it creates, any functions, to all have access to a bunch of bonus functionality. You can use any language. An array in Ruby, or a dictionary in Python, they all have access to certain functionality. Well, where's that coming from? Well, in JavaScript, it's coming from using its own very prototypal nature to give access to a bunch of shared functions. They're not mysteriously under the hood, hidden away. They're right there. I can literally go console log obj dot underscore product underscore dot has own property, and it will show me that function that I can use. It is right there. These are not buried. These are not like implementations in JavaScript, under in machine code under the hood of JavaScript. These are JavaScript implementations. Very interesting. Okay.
This is a JavaScript implementation of this nature, especially on the object, because the object, bear with me, everything in JavaScript is objects, and there are special type of objects that has this function attached to, which is our object combos. So for example, in the case of objects, you have now a function constructor, or in other words, you have a property called prototype. This is by design. If you don't trust me of what I'm telling you,
We're going to do some pair programming to start doing in our first.
if you don't trust me what I'm saying, just I won't blame you. Let's gonna take a look at the spec, and here we're gonna say, hey, the object, okay, on ECMAScript, exactly, but not promise object. You're gonna see is the objects in general, bro. In general, so executable code and execution go. Now let me take a look at the object here. Clause, terms, broad, object type, object type, the object type. That's right, exactly. So you have is the undefined, the null, boolean, string, the number, okay, as well as the object. Truly, the only thing that actually exists here is just the undefined, absence of value. The null, it exists but points to nothing. The undefined is the absence of existence, so this doesn't exist. The null is that, hey, this exists but doesn't have any value. Boolean, string, symbol, number, and then the object. So here on the objects, as you can see, it has a data property like so, as a key value bearer, a set of Boolean attributes, an accessor property like so, all right? And the property of an object are uniquely identified using the property key. Property key is either a string or a symbol. All strings and symbols include the empty string, are valid as property key. A property name is a property key that is in a string. And an integer index is a property name, such as canonical numeric index return an integral number in the inclusive interval. But I want to take a look now at the properties of the product. So property attributes, so far we have defined that this object type simply refers to the key and the value, where the key is the property, and that property has the value, readable, get, set, all of these properties. Okay, most of the time we can actually access to that property, we access through the value. Okay, especially if you want to write, okay, you can assign a new value to that, or the setter. You have now access to prototype accessor properties like get and set. This is again hidden values from that, as well as enumerable and configurable. This is because they are the hidden property for them. Okay, they are hidden property for them. Okay, now when it comes to take a look, what are the methods from these objects? Okay, now is when we look at this. Okay, the actual semantic of object and ECMAScript are specified via algorithm called internal methods. Each object in ECMAScript engine is associated with a set of internal method, that defines its runtime behavior. But as you can see, any times that you create an object, it has a inner methods, or a set of internal methods that define that's defined, it is runtime behavior. So because after all, JavaScript is this interpreted language. You're going to do one line after the another, right? It's not compiled. So the nature or the variable here, we're going to change all the other sometimes, as well as the objects. So it needs to find a way of how it can keep track of how these objects are changing, all of this data is changing. So these internal methods are not part of the ECMAScript language, okay, and they are defined by specification purely for expository purpose. However, each object with an implementation of ECMAScript must have a specified by the internal method associated with. The exact manner in which this is accomplished is determined by the implementation, by the browser. But again, must behave in the specific by internal method associated with it. So internal methods names are polymorphic. This means that different object value may perform different algorithms. Okay, when a common internal method name is invoked upon them. So polymorphic means that different object values may perform different algorithms. So depending of how this object is, or depending how the value of this object has, it performs differently. So you can think of this that depending of where this depend which language this person talk, we're going to now run or detect some context, different context there. Okay. If at runtime the implementation of an algorithm attempts to use an internal method of an object, that the object does not support a type error, exception is thrown. Internal slot corresponds to internal state that is associated with objects and used by various ECMAScript specification algorithms. But again, table 4 summarizes the essential internal methods. Okay, so an ordinary object is an object that satisfies all the following criteria. For internal method listed in table 4, the object use those defined here, like so. So it has all of these internal methods: get prototype of, set prototype of, is extensible, prevent extension, get on property, define on property, has property, get, set, delete, and own property keys. Okay, if the object has call internal method, it is used either to one define here, okay, or define here, or the call or the construct, exactly, or the construct, okay, because it's a running execution context, it's creating that. That's quite interesting. An exotic object is an object, okay, if it is called and if it is construct. So ordinary object internal method and internal slot. You get is it get prototype here, set prototype here, ordinary prototype, and all of this hidden property that we see before, which is this. So an ordinary object is an object that satisfies the following criteria, and an exotic object is an object that is not an ordinary object. Okay, so this specification recognizes different kind of exotic object by those objects' internal methods. An object, this is behavioral equivalent to a particular kind of exotic, such as an array exotic object or bound functions exotic object. Bound functions bound functions exotic objects. For example, call. Got. All right. All right. So all objects here now follow this property. You know, it has internal methods listed here, okay, as well as a call or construct here. An exotic object is an object that is not an ordinary object, and they are particularly objects like array exotic or bound function objects like so. The signature column table 4 and other similar tables describe the invocation pattern for each internal method. Then the name describes the required type of a completion record. Exactly. Additional essential internal methods of function objects. Essential internal methods. So that's when they define here this exotic objects or normal objects. But to not make this much more complex, that can be quite and I will let you now this reference here of the object here. Now where are the F? Now what the French tells us is the object type here. Okay. That's quite interesting, bro. That's very, very interesting. Yeah, that's very, very, very interesting.
Line of that object, by default, as all objects in function-object combos has what property do we think, Chris? What all objects in function-object combos have a property by default?
Prototype.
Fantastic, thank you, Chris. Yes, prototype. Well done, man. Which is itself a big old object. See on it here. It is right there. These are not buried. These are not like implementations in JavaScript under in machine code under the hood of JavaScript. These are JavaScript implementations. Very interesting. Okay. So what this means, folk, is when we in our creation of user 1 get an object that says name Phil score 4 underscore proto underscore is user creator dot prototype, go grab those functions there. Well, hold on. Do we lose access to has own property? No, because that, I'm going to see all this in a moment, don't worry. That object that has increment and login on the prototype.
For real? Where are you, man? What? Anyway, here we are. enough. Okay. So this is our diagram. You got it. Nope, it's not. In fact, is this. All right.
Object itself has is an object. So it itself has a proto reference, a proto property, which links up to object.prototype. It's a chain of links up. And all we do is we intercede in that chain. We say, okay, user one, your proto, we'll see this one in a moment, your dunder proto dunder is going to refer to user creator.prototype, which is an object. That object has its own dunder proto. So if we don't find has own property on that object, because we only got increment of login on there, we head up to the next one, object.prototype, which is where it's at. Exactly. Let's also see on that same note, arrays and functions are also objects. So they get access to all the functions in object.prototype, but they also get extra goodies. Okay, before we do this, I'm going to tell you that when JavaScript loads, there's another thing that it gets for free, which is another function object combo with the label function. And this function object combo, is a function, hopefully. But of course, it's therefore also, because a function object combo.
It's an object.
Yeah, don't get confused by the fact they've got uppercase. They're just function object combos, but they're ones we get built into JavaScript. This function in its object form has
a prototype.
David? Prototype, fantastic. Yeah, people, forgive me for these slides. This is the bit where I'm like, I just want to make sure you know about this. We're not going to use this heavily, but I really want us to have like the core diagrammed version of what is the most like intricate, finicky part of JavaScript.
Finicky.
It also has an object.
very finicky.
And that has in it a whole bunch of functions. It's got toString, all the functions that we hope any function will have access to. You know when you go like multiply by 2 dot call. Well, where's that call coming from? It's not a multiply by 2 object. Multiply by 2 dot toString. Where's that toString coming from? Not a multiply. Well, we'll play this out in a second.
Exactly. In this case, it has the toString. That's right. The toString. This is where is this method?
Lay this out to start with. toString. It's got like call on it. Secondly, there's some other ones that functions have access to.
And then you got the function.prototype here. toString, function call, function bind.
Besides call, anyone think of others? Bind, fantastic.
Bind.
You said bind? Yeah, Seth, spot on. Bind, and there's apply. Yeah. I think there's only like 2 others. There's very few others. Okay. So now everything in orange, everything surrounded by orange, we did not declare. It was put in there for us as soon as we turned JavaScript on.
And now it is time to take a look at the function object type. Okay. What is a function? Function object. Function go. Function object. I think it is function object. That has the call. Okay, a list of record specification and a construct. This is a class, function here. Member of the object type that may be invoked in a subroutine. Function object. Function objects. Exactly. Fundamentals. Fundamental objects. Okay. Object and the function object. Boolean object, symbol error, and error objects. Okay, this is part of the fundamental object. Okay. Holy moly. is function is the initial value of the function property of the global object. Create and initialize a new function object when called a function rather than a constructor. So this is now the function itself here and the property of the function constructor, which has a prototype exactly. And then down the line we have is the property of the function prototype. Is in itself a building function object as at any argument if I have a construct and it has a prototype here. This is the property that it has this. Which is on the prototype here it has apply, bind, call, constructor, and to stream. Interesting. Very, very, very interesting. Oh my god. So by default, when the JavaScript engine start, it creates this object function. Exactly, it creates this object function. Exactly, it creates this object function combo. Okay. God damn it. Exactly. It creates this object function combo here. Alright. So we got these abstract operations like so. I just want to take a look at the national convention, conformative, ECMAScript data types and values, syntax direct, executable, the global object, numbers and date, text processing, indexing, key structure, structured data, managing memory, control access, control abstraction objects, reflection, the memory model. Even the memory model, they changed that. A shared data block. Okay. And again, this is quite beyond the scope of this because you just wanna is to take a look now at the, this is from the function. Okay, function objects, and then I wanna look is at the objects, objects here. Exactly, part of the fundamentals here. Okay, all right. So part of the fundamentals, property of the object constructor. Okay. Oh my god. The JavaScript engine started create properties inside of the function prototype exactly. So by default, when the JavaScript engine start, it create properties inside of the prototype. Okay. So C ECMAScript. That's quite interesting, by the way. That's quite interesting, bro. Script object. properties. Okay, where you have things like when you have things like assign, create, define property, entry, freeze, all of it, group by, which is something new. Group by the way, group by is something new. Object, you take a look at here. Object, okay, thanks for the group by, bro. Completely thanks for the group by. Oh my god, thanks for the group by. Yeah, thanks for the group by. Jesus, holy French toast. Holy French toast. Group by, oh my god, but group by is newly available. Group by is newly available. Exactly. Group by is newly available, bro. It's so new that it's only 21. Polyfill object group by in Core.js. God damn. That's why a lot of people actually using Core.js. This is a library that is damn. Oh my god, Core.js is what allows now polyfill of JavaScript standard library. From ancient EX5 feature to bleeding edge features like iterator helpers and web platform features closely related to the ECMAScript. Holy moly, bro. Oh my god. Those mother they are using it. Those companies are using it. Netflix, eBay, About, Futurama, even Pornhub, Spotify. God damn it. Webalizer. With what GS library are more widespread on website? It's not React, it's not Lodash or any other more. I'm pretty sure only about good old jQuery, bro. And Core.js is not only about websites front end. It's used almost everywhere where JavaScript is used. But I think that's more than enough statistics. Yep, a project some random person in Nebraska has been thankfully maintaining since 2003, bro. That's right. All right. Mm. All hail, bro. Holy moly. Okay. This is a long. Whoa, holy. Okay, this is a long story here. Long story. Long story. One of the most heavily used package in the web. Or, sorry, on the web. One of the most heavily used package on the web. All right. Okay, it makes a ton of sense. So now, let me, well, I already closed that. I shouldn't do that. Is this one, so all of this property. That makes sense. As well as this instance method, which are part of the objects, which are part from the object prototype, which are part of this share method that you're gonna get that. That makes a lot of sense. That makes a lot of sense. Instance property here. Object and object function. As you can see here. You can see the object. Alright. Interesting. This is part of the fundamentals objects. So this is not the object. This is standard built-in object. Object. Interesting. So this is object. Object. Okay. Indian docs. That makes a lot of sense. Docs. MDM docs here. All right, that makes a ton of sense, bro. Object MDM docs, and then you got is the function object. Okay, holy moly. And then you got is now the function here.
Okay, so now let's walk through this code, knowing that these bits are here. Line 1. Elliot, what are we doing?
We're declaring a function multiplied by 2.
No, I've got no room in my memory. Okay. Declaring a function multiply by 2. Help me out here, man. It's a function object combo. Exactly. Elliot's at this point like, it's not. We got it. Exactly. And that object, because it's a function object combo, well, we know it has a prototype object as well, but we don't probably use that, people, right? We don't use that bit unless we call multiply by 2 with a new keyword in front, which gives us our objects that have a link to that prototype object. Otherwise, we never use this bit. It's a bit redundant. It's kind of weird why we always have it there just in case. If we ever were to try and run this function with a new keyword, return out objects which have a link to this object. We would never otherwise use it, I don't think, maybe. Okay, now, things get interesting. Multiply by 2 dot to string. Multiply by 2 to string. Hard line here. Terry, talk me through the lookup process. Well, we've got to find that thing first.
Exactly. We need to find the multiply by
I don't even know
2
where it is. Let's do the lookup process. Where's multiply by 2?
Global.
In global.
in global because it was defined
Excellent.
previously.
Elliot, which bit of multiply by 2 are we accessing? The function or the object?
The object.
The object. See? Dot notation. It may see an execution context on the end here, but it's not on multiply by 2. We've got to go find this thing, whatever it is, to string. We look for it on the associated object, because when we use dot notation, we look, just like if we go multiply by 2 dot prototype, we'd find this empty object. We're going to go multiply by 2 dot string, and we're looking through the properties of multiply by 2 in its object form. Chris, do we see something called toString? No, it's not there. Do we panic? It's an object, so what property does it automatically have, David?
Proto.
Proto. All objects have underscore proto underscore. Now, where, David, do you think this dunder proto dunder is going to refer off to?
To the global object.
That would be thoughtful, but this here is a function object combo where we want this
So first it's going to take a look at the
function to have access to
multiplied
certain
too.
bonus functions that are only available to functions but not available to objects. So our object we made earlier, that points off to this object because we want it to have access to the object-specific methods, like has own property. But this multiplied by 2 is a function that happens to have the attached object. And that means we want our function to have access to some things which are specific to functions, like call, bind, and apply, and toString. So, David, do you want to try take another shot at where you think that proto, which object full of functions it might point off to?
A function.
You're going to point to the function.
To the function.prototype object. Off it goes
To the function.prototype
to the
object.
function.prototype object. And that means, Seth, talk me through the actual lookup we're going to have now when I try and run toString on multiply by 2, hoping to find there's a function called toString.
Didn't we just do that?
But we did. I want you to talk me through the whole again.
Oh, okay.
So-
So it looks up to string on the multiply by 2's object.
Right,
Does
so
not
there's a
find
function,
it.
yep, doesn't find it.
It looks in the prototype, which is
It's looking at the proto that has a reference to the prototype functions object constructor.
Looks, yeah,
proto,
proto
which is linked to the function's prototype.
function.prototype object, where what does it find?
toString.
toString. Oh, and it grabs its code and runs it. Function. Oh, well, what about though if I want to now use? Oh, this is so brutal. What if I now want to use my function that was available to objects via the proto reference to object.prototype? Maybe now I don't get access to those. Maybe I can't do multiply by 2 dot has own. Maybe I can't do multiply by 2 dot has own property. I don't know what we're putting in. Score. Maybe I can't do this line now. Let's see. Who? Raise your hand if you want to take a shot at the journey of finding or not finding. It's Nick, go ahead.
Yeah, I mean, it's like, well, first we're going to take a look now at the multiply by 2. What is multiply by 2? It's a function. All right, so this is a function object combo, which means that let's going to see if this property that we want to access called this function that we want to access called has own property is on the object multiply by 2. It is? No, it's not. Do we panic? No, not at all. Now, then we take a look at the prototype. Why is that? Because multiply by 2, after all, is a function object. So anytime you define a function, is function object combo. So inside of that, we're going to take a look now at the has own property. Do we have that? Okay. This is quite interesting because it's like, where is going to find that first? It's going to find that first on the prototype.
My friend
So it looks for multiply by 2 in the memory,
finds it.
and then it looks for has own property.
Is
in
that
it.
has own property?
No.
Is that has own property? Oh, no, but.
But
No, but it has a reference
goes, see what proto is referencing, which is
to, it has a proto to the
function
reference of the
prototype.
function
That's
prototype.
I'm even caused by saying that it's the function
dot,
dot prototype object. Yeah.
prototype object, and it looks for has own property
Is
in
this
there.
it?
No,
This-
it's not there.
But
So
what
then
do
it-
you think this
But this object has also a reference
object might have on it?
is
Its own
to
proto, which references the
Perfect.
object.
Can we give Nick a round of applause? That was excellent, man. One of the hardest things. Fantastic, man. Exactly that proto, which references up to this prototype object. Where what do we find?
Has own property.
Has own property, and we can use it.
the prototype chain, bro. Oh my god. And it all start with this. And it all start with this, bro. And it all start with this. And it all start with this.
Now we see it's called a prototype chain. It is JavaScript
Exactly.
prototype on nature. So when
Nature.
it doesn't find something on the first object, it looks to its proto reference to another object. Doesn't find it on that one. It still checks the proto. What is this object? So we did. I suppose we had multiply by. I haven't done
It points to
multiply
null.
dot
It points to null, which is, hey,
increase.
this is the end.
Let's do the journey. Multiply by 2, look on its object version because it's dot notation. Prototype's not it, there's no increase function. Look to its proto, which takes us to this other object full of functions. Increase not there, increase not there, increase not there. Look to its proto. Still doesn't have one called increase. Does this have a proto? Well, of course it does. But what is its proto refer to? To null. Stop looking. There's no further up this chain. And so then we get the error. This method does not exist. Okay, people. That is the under the hood chain of.
The chain prototype. So if we trying to check a process, if we're trying to check a method here, exactly, if we're trying to check a method that doesn't exist, it will try to look up. It will try to look up to the It will try to look up. It will try to look up the prototype or the proto change or the prototype change. The proto change here. If we're trying to check a method that doesn't exist, it will try to look up to the prototype change where the last pointer, which is our object, where the last proto pointer, which is our object, is null, which means stop looking.
Proto references known as JavaScript's prototypal nature that gives objects, functions that would otherwise not be available on them through this referencing link up. And what we do, because we never lose access to these, well, we can actually overwrite the access to them, but what we tend to do is give our objects access through their proto to an object full of our own functions, knowing that that object full of functions will have its own reference up to this object full of functions, so we don't lose access. And we're going to use that fact to allow us to create objects that, they use the word inherit, I don't love this term in JavaScript, but to get access to functions that were available to, let's say we have user objects, user 1, user 2, user 100, that have certain properties and certain functions available to them. But now we want to create in our app slightly more specific type of users, called, paid users. We have paid user 1. Paid user 1 wants to have access to most of the functions that users had access to. User 1 had access to, user 20 had access to, but may also want to have specific functions that only a paid user will get access to, like, increase account balance. If you're not a paid user, you don't have an account balance. So increase account balance. But it doesn't want to lose the ability to also increase its score in our quiz game. So maybe we can have functions that are only available to one type of object, and then that set of functions would have a link up to another set of functions, one layer up. So we get both of these. But we have
Proto is now private method and not exposed by default on the object.
proto access that top layer of functions.
Get prototype off to grab the object prototype. Oh, because they update the language. Now, proto or disclaimer. proto disclaimer. Now proto is a private method. Exactly. To use proto in controversial is controversial and discouraged. It is existing and exact behavior has only been standardized as a legacy feature to ensure web compatibility, while it presents several security issues and FUD guns. For better support, prefer object.getPrototype off, reflex get prototype off, object.set prototype, and set prototype. Okay. Instead of that, object.getPrototype off. Exactly. Since now this is not exposed by default on the object, you should use the object.getPrototype off as a way to get the reference from that, to grab the object prototype. Exactly. To grab an object prototype. So that'll be all for this video. Take care. Bye bye.